Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we are gonna solve this problem that you can see on the screen. This is 2.15 from chapter 2. Okay, this is chapter 2 from 11th standard CBSE. Okay, physics. Okay, so this problem we are gonna solve in this lecture. Okay, in the same playlist you can actually find out all the problems, okay, all the concepts from the same chapter. If you want, you can check that also. Okay, now let's move on. Okay, let's move on to this one. 2.15, it says that a famous relation in physics relates moving mass m, okay, moving mass m to the rest mass m naught, okay, to the rest mass m naught over here of a particle. Okay, a famous relation in physics relates moving mass m to the rest mass m naught of a particle in terms of its speed v and the speed of light c. Okay, speed of light c. So just see here, there are four physical quantities that are given: m, m naught, okay, v and c. Okay, I mean actually there are two physical quantity. One is this mass and other is this speed. Okay, so these are the two quantities given over here, but there are two masses actually and there are two speeds also. This is the moving mass of the particle, okay, or we can say mass in motion, mass while the body is moving. Okay, it is called as moving mass, and this m naught is a rest mass, mass when it is at rest, and v is the velocity with which it is moving, and c is the velocity of light or speed of light. Okay, so these are the four quantities which have to be related. Okay, there is actually a famous relation which relates all these quantities, which comes from the Albert Einstein's theory of relativity. Okay, so see here what is given. This relation first arose as a consequence of special theory of relativity, okay, due to Albert Einstein. A boy recalls the relation almost correctly. That means there is some boy actually, let's say in a class, and his teacher asks, tell us that relation. So that boy, just recalls that equation almost correctly, but he could not recall it perfectly. So he writes something like this. He says, yes, this is the equation. Okay, he says this is the equation. So the question is this right equation? Okay, the question is this. Is this a right equation? Is there any problem with this or not? Okay, so he writes like this. We have to guess. Now you can see here, he forgets where to put this constant c. Okay, because you can see there is no c here. Okay, there is no c here. C is the speed of light. So he hasn't put that c over there. We have to find out. Okay, we have to guess where to put the missing c. That is our task over here. Okay, so it's a very simple question, just a discussion kind of a question. See, the mass is there, okay, m naught upon 1 minus v squared raised to 1/2. Okay, yes. Okay, now we have to find out the place for c. Place for c over here. Okay, then only we can do this. Yes. Okay, so what we can do is we can use the dimensional analysis, right? Okay, dimensional analysis. If you use the dimensional analysis, we can actually get the position for this c actually. Okay, we can find out where to put this c using the dimensional analysis. According to the dimensional analysis, as we know, the dimensions on both sides must be equal. Okay, dimensions on LHS should be equal to dimensions on RHS. Okay, that is the main condition. If that is equal, then the equation is said to be correct. But here if you look at this term, okay, I mean this whole term over here, okay, this has got some other dimensions than this quantity. Here we have only mass, so the dimension for this would be m raised to 1. But here you can see there is m naught. Okay, that means there is a m raised to 1 here, divided by this quantity also has got some dimensions, but right now we can't solve this actually because there is a power also, okay, and there is 1 also, so we have to use some mathematical methods. But one thing is sure, that yes, there will be some dimensions, okay, because there is a velocity, so at least we can say there is L raised to 1 T raised to minus 1, right? Because this is the dimension of velocity. At least I'm saying that this should be the dimensions in the denominator. So you can see that the dimensions on both sides are not equal. That means what? This equation is not correct. So we have to do something to make it dimensionally correct equation. You can see there is a mass here, here is a mass. Okay, so these dimensions are okay. These dimensions are correct. So if you want to make this equation dimensionally correct, okay, you have to make the dimensions on RHS equal to m raised to 1 only. Okay, m raised to 1 only, because on the LHS we have m raised to 1. Okay, that means 1 is the dimensions of mass. Okay, so that should be the same thing. So that means we have to cancel out this one. You have to cancel out this one over here. Okay, somehow we have to do something and we have to actually cancel out this one. So that means we have to put C in such a way, that the dimensions in the denominator cancels up. Okay, so let's see what we can do here.